Today you'll be simplifying roots and radical expressions. So the definition of the nth root. If a to the nth power equals b, with a and b real numbers and n a positive integer, then a is the nth root of b. Here are some examples off to the left. If we have 5 squared equals 25, then 5 is the square root of 25. If we have 5 to the third is 125, then 5 is the cube root of 125. And 5 to the fourth of 625, 5 is the fourth root of 625. Now, if n is odd, then there is only one real nth root of b, denoted in the form as the nth root of b. The only nth root of 0 is obviously 0. If I am doing an even and b is positive, there are two real nth roots of b. Okay, and its symbol is the nth root of b, obviously. So the negative root is its opposite, or negative nth root of b. And b is negative, there are no real nth roots of b. So notice the radicand, that is the number under the radical sign, seen here. And the index is the root, right? Or the number in the check mark. And obviously the radical sign. So we want to know what are all the real cube roots of negative 0.08, negative 1,000, and 1 over 27. The easiest way for us to do a decimal, because this next upcoming formative is more than likely without a calculator, we know that 0.008 is the same thing as 8 over 1,000. And when we cube root 8 over 1,000, it's like we're doing the cube root of 8 over the cube root of 1,000, which is 2 over 10. And we would change it back to decimal because we were given originally a decimal point 2, and that's it. Now, we have to ask ourselves, is this an odd root or an even root? Well, because this is odd, there's only one nth root. Okay, if we look at the next one, the cube root of 1,000. Well, that's just 10. And because it is an odd root, we don't need to worry about two of them. And then, last but not least, the cube root of 1 over 27. We would do the cube root of the numerator over the cube root of the denominator, which would be 1 over 3. And because we were initially given a fraction, we would just do a fraction. In our next example, we're going to find all the real square roots of negative 0.81, 25 over 49, and the square root of 121. So, the square root of negative 0.81, do we have, because it says what is the real square roots, we don't have i's in any of our answers. So because it is a negative under an even radical, we just say none. Okay, and that's it for that one. For 25 over 49, the square root of 25 over 49 is the square root of 25 over the square root of 49, which is just 5 over 7. And because it's even, you need to put the plus or minus. And the reason behind that is because square roots can be positive or negative. Meaning, since something like 11 squared is 121, and something like negative 11 squared is also 121. So you have to put that plus or minus. And then the square root of 121, well, it's an even root, so we need that plus or minus, and we just have 11, which we kind of already did. Take a minute or two and try the example you tries. Okay, so hopefully for the fifth roots, for fifth root of 0, 0, the fifth root of negative 1, because it is an odd root, we can do the fifth root of negative 1, it is negative 1, and the fifth root of 32 is 2. for the real square roots of 0.01, we should get plus or minus 0.1. For negative 1, 0, or meaning none. And for the square root of 36 over 121, it is an even root, so we need plus or minus 6 over 11. So if we look at our next set of examples, we're going to find what is each real number root. Okay, so because this question doesn't say what are all the real roots, we don't need to worry about any pluses or minuses for evens. Okay, so let's look at letter A. Hopefully you recognize that 0.36 is the same thing as 36 over 100. And when we square root the numerator and denominator, the square root of 36 is 6 and the square root of 100 is 10. Now because our original is in decimal form, it's okay to say 0.6. That's it. If we look at B, notice we have the cube root of negative 27. Remember, you can do a factor tree. So we know 3 times 9 is 27, and 9 breaks into 3s. And anything I've broken down, I just cross out. Because the index is 3, I have to have 3 of the same number in order to come out of the radical. So we need a 3. And remember, when you cube root a negative, your answer needs to be negative. And that's it. C tends to trip up people. Okay? Remember, if you are square rooting a negative 17 squared, just like with order of operations, you're going to do the parentheses first. So we're thinking of this as the square root of 17 times negative 17 times negative 17, which would be the square root of 289. Okay? So this one would just be 17. And if we look at D, remember, because it's an even root here and a negative under the radical sign, we don't have any valuable solutions. Now I want you to take a minute or two and try the example you tried. Hopefully you found for the square root of negative 49, because it's an even root, you cannot do it unless it has an I. We want real numbers, not complex. B, because it's an odd root, you can do the fifth root of negative 32, it is negative 2. And for C, remember, we're thinking of that square root of negative 5 squared, like the square root of 25, so it would be 5. Okay, nth root of nth powers. So for any real number A, nth root of a to the nth is a if the n is odd. Absolute value of n if it is even, meaning if n is even, you need the absolute value. If n is odd, no absolute value. Okay, let's draw another thinking bubble and illustrate what it is we're thinking. So think of it as follows. So if you take the even root, okay, if you take the even root, okay, so if you take an even root and the exponent is now odd, you need the absolute value. So for example, if you had something like the square root of negative 2 squared, right? Okay, that is the same thing as saying the square root of 4, which we know to equal 2. It does not equal negative 2, okay? This is why you need absolute value, okay? So let's look at some examples of what we're talking about. If I have the square root of 25a to the 4th, we know the square root of 25 is obviously 5. And the sets of 2 and a to the 4th are 2. Okay, so because we go from an even power to an even power, meaning when I square root a to the 4th, I get a squared, I don't need absolute value. However, if we look at the next example, sets of 4 and p to the 12th, well, that would be p cubed. Okay? Do you go from an even power to an odd? The answer to that is yes. So you have to have the absolute value signs around the p. What about the q? We know sets of 4 and q to the 4th is just 1, so we have q to the 1st. But because we go from an even power to an odd power in our answer, we need the absolute value signs. Let's look at the next one. Okay, we know we have the cube root of 8, which we know to be 2. Sets of 3 and a to the 6th would be 2, and sets of 3 and b to the 9th would be 3, so b cubed. And we don't need absolute values because we're not doing an even root. Now I want you to take a minute or two and try the example you tried. So hopefully you find a for a, 9x squared, for b, a to the fourth, b to the fifth, and c, the absolute value of x to the third, y to the fourth. And the reason why the x is absolute values, because in the original, under the radical, you had an even power, and when you take the fourth root of that even power, it is now odd. Last example, the speed s in meters per second of a car leaving a skid mark d meters long after the brakes are applied is given by s equals the square root of 15d. If you measure a skid mark and it is 180 meters long, how fast was the car going before it braked? Well, we know we're going to have s equals the square root of 15 times our distance. So we had a distance of 180. And we want to know what this is. Okay, well, we're going to reduce the radical down. If it were me, I would not waste my time multiplying 15 and 180. I instead would break down all my numbers into things I can start pairing with. I know 3 times 5 is 15. For 180, I know 10 times 18 is 180. And 10 breaks down to 5 and 2. So look, we already have a pair of 5s. 18 breaks down to 2 and 9. And we have a pair of 3s. And anything I've broken down, I like to cross out so I don't get confused. And because we're doing square root, remember we want sets of 2. So we have 2 5s, 2 2s, and 2 3s. So our final answer, we're going to have a 5 come out of the radical, a 2, and a 3. And what stays inside? The 3. And I'm just going to multiply the 5, 2, and 3 together. So this should give us 30 square root 3 miles per hour. And that's it. Time to practice and math humor.